All right, at the county beach, the lifeguard policy states that one lifeguard is required for up to 50 swimmers, with an additional lifeguard required for an additional 25 swimmers. The maximum allowed swimmers, S, in the water given L. The number of lifeguards on duty is represented by this equation. The beach schedules up to 8 lifeguards on busy days. So what function family is being represented? So in this case, there's nothing special going on with your variable, so this would be a linear. It's plain L. There's nothing else going on with the L. There's no exponents, no parentheses, or anything like that. All right, then it's asking me, is it discrete or continuous, and why? So let's think about what L represents. L represents the number of lifeguards. And because you can't have half of a lifeguard, it's going to be discrete. Can't have half a lifeguard. And then we want to determine the domain and the range. So remember, when you're determining the domain and the range, you have to think the min and the max. And we also have to know the variables. So the domain variable, if you look here, domain is normally X, and in this case, it's lifeguards. And so the range, which is S, where does it tell me what S is? S is swimmers. All right, so the beach schedules up to 8 lifeguards on busy days. So that is the maximum number of lifeguards that's going to be scheduled. They can schedule 0 lifeguards, 1 lifeguard, 2, 3, 4, 5, 6, 7, or 8 lifeguards. Because it's discrete, you have to actually list it. All right, and so then using the function, we're just going to list the range. So you can use your calculator to plug in this function, 50 plus 25 x minus 1, and then go to the table. Of course. 50 plus 25 x minus 1. Oops. All right, so you probably can't, I don't know if you can see it or not, but 0 is going to be 25, and then 50, then 75, then 100, then 125, then 150, then 175, 200, and at 8 it's 225. And so when it's discrete, you are just listing. You're just listing domain and range. All right, let's look at problem 12. Will is making the 50-minute drive home from an away game. The distance remaining is represented by this equation where t is time in minutes. All right, so t is my variable. This is going to be continuous because you can have part of a minute. Part of a minute is okay. All right, so you can have seconds, milliseconds, so you can have parts of minutes, and you can have parts of distance. So this one, when we're doing our domain and range, we can do it in interval notation. So the drive home is 50 minutes. Oh, and then we got to figure out our variables. The variable in the x spot is t, and so t stands for time. So domain is going to be time, and the variable in the y spot is going to be the d, so d stands for distance. And so your range is going to be distance. So the smallest amount of time is going to be 0. And my biggest amount of time is going to be 50 because it's a 50-minute drive home. And then same thing, you are going to plug this in to your equation. Now, if you want to, you can plug it into the main screen because we just really need to know when the time is 0, 1.08 times 0, what's the distance going to be? Well, it's going to be 54, and that makes sense. And then when the time is 50, what is the distance going to be? Well, it's going to be 0, and that also makes sense because he's going to be home and I really need to switch these around because you have to go small to big. So smallest distance is 0, biggest distance is 54. All right, almost done. All right, on the back page, it is talking about parent functions. So you just got to know your parent functions. Right